According to the National Electrical Code, replacing a circuit breaker with one of a higher rating is permissible only under specific conditions. Firstly, the existing circuit must be operating within its originally specified capacity. Secondly, the new breaker must be of the same type and interrupting rating as the one being replaced. Thirdly, and most importantly, the circuit conductors themselves must be rated to handle the increased amperage that the new breaker will allow. For lighting circuits with multiple fixtures, calculating the ampacity, which is the maximum current carrying capacity, is crucial. The formula to determine this is ampacity equals total watts divided by voltage, then multiplied by 1.25. Here, total watts represents the sum of the wattage of all light fixtures on the circuit. Voltage refers to the circuit's voltage, typically 120 volts or 240 volts in many applications. The 1.25 multiplier is a load factor specifically included to account for the continuous nature of lighting loads. Considering a scenario where the original circuit has a total wattage of 2860 watts operating at 120 volts, the original current is calculated as 2860 watts divided by 120 volts, multiplied by 1.25, which results in approximately 29.79 amps. If the lighting is on a 240 volt system, the original current is calculated as 2860 watts divided by 240 volts, multiplied by 1.25, which results in approximately 14.89 amps. Now, if a second lamp is added to each fixture, effectively doubling the total wattage to 5720 watts, the new current draw changes significantly. Using the same voltage of 120 volts, the new current is calculated as 5720 watts divided by 120 volts, multiplied by 1.25, equaling 59.58 amps. If the lighting is on a 240 volt system, the original current is calculated as 5720 watts divided by 240 volts, multiplied by 1.25, which results in approximately 29.79 amps. If this new current exceeds the rating of the existing circuit breaker, for example, a 20 amp breaker, it raises a serious issue. The NEC strictly prohibits simply replacing the 20 amp breaker with a larger one, such as a 30 amp breaker, without addressing the underlying problem of overcurrent. When faced with an overcurrent condition, several options can be considered. One option involves splitting the circuit into two separate circuits. This would necessitate the installation of additional wiring and another 20 amp breaker to handle the increased load. Another option is to reduce the number of fixtures on the circuit or decrease the wattage of the lamps used in each fixture. This would bring the total load back within the capacity of the existing 20 amp breaker. A third option could involve installing a lighting transformer to step down the voltage, which in turn reduces the current flowing through the circuit. This approach might be more complex and costly but could be suitable depending on the specific circumstances. As for the existing three-way switch, it might not be adequate to handle the increased load resulting from the doubled wattage. In such cases, replacing the existing switch with one that is specifically rated for the higher current is essential to ensure safety and prevent potential failures. In many situations, splitting the circuit into two separate circuits represents the most practical and reliable solution. While it might involve additional upfront costs, it ensures compliance with electrical safety standards and eliminates the risk of overcurrent issues, which can lead to overheating, damage to wiring, and even fire hazards. Electrical safety is paramount, and any modifications or upgrades to electrical systems must adhere to the NEC guidelines and be performed by qualified professionals. Considering these factors, the most prudent approach typically involves splitting the circuit to maintain safety and code compliance. The National Electrical Code Section 210.23 A1, which addresses branch circuits, states that for 15 and 20 amp circuits, the total cord and plug connected equipment shall not exceed 80% of the branch circuit rating. This means that on a 20 amp circuit, the continuous load should not exceed 16 amps. Lighting loads are typically considered continuous, therefore this requirement is applicable. Section 210.20 requires overcurrent protection devices to be protected where subject to physical damage. Section 210.19. A1 addresses the ampacity of conductors. Branch circuit conductors shall have an ampacity not less than the maximum to be served. Conductors must be sized appropriately for the load they will carry. Section 210.19. A2 addresses branch circuits that supply luminaires. The branch circuit shall have sufficient capacity for the luminaires connected to it. It also explains that a branch circuit supplying more than one luminaire shall be calculated with the load of 125% of the luminaire load. So to reiterate, increasing the breaker size without addressing the wiring and overall circuit design is not an appropriate solution. The NEC prioritizes safety and proper sizing of components to prevent hazards. The existing three-way switch is also a component that needs to be evaluated. Switches have current ratings and must be suitable for the load they control. If the new load significantly exceeds the switch's rating, it needs to be upgraded to a switch with a higher amperage rating to prevent overheating and potential failure. It is a bad idea to simply install a larger breaker without evaluating the entire circuit and addressing the underlying issues. The best solution is to engage a qualified electrician to assess the situation, perform the necessary calculations, and recommend the most appropriate and safe course of action. In regards to Massachusetts Electrical Code, Massachusetts adopts a version of the National Electrical Code. However, it may contain state-specific amendments. Therefore, all work must comply with these amendments as well.